If you were a dog with superpowers, what dog with what superpowers would you be?
Maybe you can put.
Is it on already?
That makes sense. They have floppy ears.
I had a Cocker Spaniel for 14 years, so yeah.
What dog, what superpower? I'm allergic to dogs, so I don't know how that's going to work out. Maybe a dog that sneezes a lot would end up.
Can dogs be allergic to dog hair? Is it kind of like an autoimmune disease?
I guess it would be, yeah.
What dog with superpowers?
Can you repeat the question, please?
If you were a dog with superpowers, what dog with what superpowers would you be? Alternatively, you can answer on a scale from -3 to 19, what is your favorite color of the alphabet?
I think I would like to be like a really, really, really dark dog that is invisible at night.
Only at night.
Yes.
That makes hunting easy. I think we can start with the panel now, huh? Thanks for joining us today. We have a really fun crowd. We already met for lunch and chatted earlier. We're speaking with Aleksandra, Kovachev, Data Science Manager, Delivery Hero, Camille van Hoffelen, Co-founder and Machine Learning Engineer at Watergenics, and Antonio Rueda-Toicen?
Rueda-Toicen.
Oh, Machine Learning Engineer at Vinted. Maybe you could start introducing yourself really quickly, maybe give a problem that you're working on so people get a feeling of what you're dealing with day to day, and then we start with the Q&A. Antonio.
Well, on a day-to-day at Vinted, I lead the estimation delivery time project, where we track how parcels arrive to customers. I don't know if you have ever used Vinted. We're a second-hand marketplace that works customer to customer. So we're actually a logistics company. We work with many different carriers, and a challenge for us is to handle these promises of delivery time while we don't control the carrier process itself. We're just aggregating the data and using machine learning to see if these predictions, these commitments that we give to our clients are something that they can be happy with. This does not mean that they are the most exact predictions. This means that we give them the predictions that cause the least frustration to them.
That makes sense. I guess it's also difficult because the users are people, and you really don't control if they don't want to send it, they forgot sending it, they gave it to their wife, right? Can you tell us a little bit more about your background? I'm always interested to hear.
I'm a computer scientist and bioengineer. I did my master's degree in biomedical computer vision. I teach data science at the Data Science Retreat. I have been doing that for 2 years. And have been teaching data science overall for the last 7 years.
Really cool.
Thank you.
Aleksandra, who are you?
Yeah, I'm privately mom of 2 young kids. I think this defines me a lot of my time and scope, but I really enjoy my profession, I would say. So, but similar, I had, before moving to Germany, I was teaching a research assistant at the university in Skopje in North Macedonia, where I come from. When I moved to Germany, my goal was to move into, to work on my passion topic, which is bioinformatics. Unfortunately, Berlin and Germany in general, I don't think it's the great place. Because of public insurance, there is not a lot of investing in this kind of technologies, I would say, or machine learning or AI for medicine. So I moved in Delivery Hero, worked in recommendations and ranking systems, where after some time I got frustrated with whatever we were building because we could not actually predict the taste of our customers. So we were just building recommendations models which were using product IDs or restaurant IDs as information without really knowing what is the taste preference, what these customers are really buying. So that's why, as I presented today, we were working last year into let's call it product level, extraction of product level metadata, and returning this information back to the other teams in delivery here to use, especially also like dish preparation time, so to estimate delivery times for the dishes. And another topic which I just recently started lead is customer identity resolution, which is also quite a different and interesting part of also machine learning, but it's a topic that requires a lot of explainability, and then you try to use first with simple methods to say, okay, these two customers are same or similar because, I don't know, they have the same last name, they use the same address, and so on. So yeah, this is my day-to-day after hybrid work. It's meetings, I have to say. Regardless if I'm in the office or I'm at home, usually a lot of meetings, stand-ups, synchronization with other teams, and yeah.
Very, very interesting. So basically, if I use Food Panda and look for lasagna, you're handling this? Not personally,
We're trying our best. Yes.
Thank you so much, Aleksandra. Camille, what about you?
Hey, my name is Camille. My background's actually in physics, where around 2014 I got dragged into the dark side of data science because I knew...
Can happen to anyone.
I know, right? If you know maths and you know a bit of coding, it's a dangerous place out there. And I did most of my career in NLP. I worked with big tech systems to do information extraction on documents. First for a company called Seal Software, then for DocuSign. And then I founded Watergenics, which is my current company, where we build optical sensors for water quality. So we basically apply computer vision methods to spectral information. And my day-to-day has changed a lot in the last 2 years, because as a founder, you start by, finding an office, hiring people, figuring out the coffee machine. Nowadays, I can spend more time on the stack and hands-on, which is my favorite part. And so yeah, I've done everything from the data engineering to the data science to the machine learning engineering, built the whole stack at Watergenics.
Really cool seeing a vast spectrum of also deep learning applied in different scales, I think. This will be very interesting. Maybe you can also start answering the first question. Where is deep learning making the biggest impact in your area?
In my area, we're very close to science and we're very close to chemistry because we work with optical methods, right? And spectroscopy. And I'm biased, but I would say that's the area where the impact of deep learning has been the most impressive, maybe in the last 2-3 years. I was actually talking to a string theorist last week.
Why would you do that?
Beers.
For fun.
It was a fun chat. You should try it. It's a good conversation, but it turns out that machine learning is an essential part of their toolkit. So you don't really go into solving equations with your pen and paper, but it's a really important tool to figure out, basically brute force certain equations, and that kind of blew my mind. I think we've heard of AlphaFold and a lot of big advances in like biotech and all this stuff, but I would say in lots of scientific niches, these tools like data-driven methods are really pushing how we learn about the world, and I think that's really cool.
Thank you. When you say impact, what are you referring to?
I guess it's driving innovation in a way or another. So unlocking new use cases or speeding up processes, right, that would otherwise take a long time, I think. And it doesn't have to be deep learning, but having this reusable framework for identifying correlations or even explaining things like we just saw in the previous talk, that kind of speed up has a huge impact on what you can find out.
Thanks so much. Aleksandra?
Yeah, I was reflecting on the question, and I think the biggest breakthrough what we see in using deep learning would be so NLP and computer vision. In my perspective, so these two topics are today very easy. They solve a lot of problems, but it's really easy to implement in company and real use cases. So this is, I think, two topics which are very, very popular, but also they have the biggest impact, in addition to the all niche other use cases, I would say.
So classic, very high complexity, high-dimensional data.
Yes, yes. But in the end, you have all these pre-trained models that you can quickly experiment with, you can test out, and then if you want to improve, you can adjust or change for your use cases. But I think that these two classes of deep neural learning application made it available for outside the academia, let's say, for the other companies.
Thanks so much. Antonio?
In my current job, I'm not using deep learning at all. It would be a waste of time, actually, to use deep learning for what I'm doing right now. We work with tabular data, and we are using rule-based approaches based on historical data, and also Bayesian regression approaches. We're doing quantal regression and Bayesian regression. And we're not using deep learning because the benchmarks that we have done against the most basic approaches show that there are no gains in this particular use case. In previous companies, previous jobs where I was working with unstructured data, with computer vision, deep learning was critical. Like, we wouldn't have been able to even start the anonymization project that we had at Parkling if we didn't have a very good object detector that would allow us to anonymize people on the streets. So that was a completely different use case.
I think it takes a very good data scientist to know when to not use deep learning. Right? Thanks so much for your input. Can you, maybe we circle back as well, how have you used deep learning within your organization to drive innovation and digitization?
That would bring me back to your point. Like, deep learning is just a tool. Deep learning is like a hammer. Like, this question is akin to asking how would you use a hammer to solve any engineering problem. It's a tool that has a particular set of applications where it has the most impact. What Aleksandra mentioned, unstructured data, vision, and text, is where it unlocks the most opportunities that one cannot.
And not so much at Vinted, you said.
At my
Not
particular, I don't mean at Vinted, at my particular data product that I'm currently working on, it makes like literally no sense whatsoever to use deep learning. But other people at Vinted are using deep learning for different things.
Thanks so much. Aleksandra, innovation and delivery hero.
Yeah, so I always say that we should start with the simplest solution first. So build your baseline, use the most simple model or faster model that you can build, and then try to beat it with more complex ones. So I have experiments like starting from recommendations, which one can say, oh, it's also a really nice opportunity to use deep learning models, is that we saw, okay, heuristic works pretty well and we cannot beat it because of underlying issues with the data, for example. So you really also need to have the right data or amounts of data and features to use meaningful, so to apply deep learning meaningfully. But then for the other project that I presented today, the dish catalog normalization, this was really necessary. So we tried with some other approaches, with experiment with some other embeddings or classifiers, but this still transformers model worked the best. And also we also saw, okay, we really need also features for the images, so we also applied this multi-model architecture that unlocked and improved our scores a lot, and it had a lot of amazing other implementations around different use cases in the company. So I think it's really comes to the back to this use case. And when I was saying for the other projects, for example, identity resolution, it's again, oh, we should use embeddings on the customer level, just embed the customer information and try to find the most similar. Yeah, it sounds interesting if you want to try out things and experiment, but it doesn't have any business usefulness because you really want to explain. Then the customer complains why I'm tagged as fraudulent customer or something. You cannot say why. Or your embedding vector was very close to another one. So you really need to, you really need to say why. So you have to say because your address or email. So you really have the information. Yeah. So there we go slow, rule-based first. Then also I think it's important make trust to your stakeholders with a simple model, show them this machine learning works, you should trust us.
Yes.
And then go to, but again, it's always, it's a balance of where you use it and when not.
I guess it's really difficult to beat a recommender system where you just show McDonald's and Subway at the top. No?
It is, it's really, but it's what people also search and
What
like.
they want. It's
Yeah.
what they want. Give them what they want. Do you see at Delivery Hero? I mean, at Delivery Hero, I think data science is fairly advanced, right? Do you see that maybe part of this advancement is from using state-of-the-art deep learning methods that also kind of is as a lighthouse to other departments?
It's again depends. Yeah. So there will be use cases where it's a must, so you would not able to solve it. But then will be use cases where you stick to the basics. But definitely, like if you want to do some advancement or you want to enable innovation, I think that's exactly you. It's one of the approaches that you go to and experiment with. So yeah.
Cool. Thank you so much, Camille. Deep learning with
Yeah.
Raman spectrography.
I think these are great answers as when considering a given use case and how would you go about applying or not deep learning to a problem. Maybe I can answer from the other side. If you have a deep learning team and you're trying to create value, can you find new problems that you can apply this to? And I think that's really challenging. Regular good product design applies where you maybe find the valuable problems first and work from there to develop solutions. But I will say we've found that a lot of innovation from that side, so discovering new applications of deep learning, came from product owners and domain experts that were well educated or learned about how machine learning development works, as opposed to from the nerds in the back who know all the algorithms and everything. So we've been pretty radical in this approach where we expect innovation to come from people who are closest to the problem and get to understand the subtleties of machine learning engineering.
There's a term in startup space that is a solution looking for a problem, which is usually not a good place to start. No?
Exactly. Yeah, exactly.
Maybe you can start with the third question already. Are there any solutions that are changing your approach to deep learning?
Totally.
That are coming out? And solutions, we discussed this before, this can be methodologies, frameworks.
Yeah, I mean, I think it's useful to split that into two. I think there's a lot on the algorithmic side that is new and helping. The whole transfer learning paradigm with pre-trained models is completely changing how we approach certain problems, or even how we deploy models and do inference. I would say efficient models, so the distillation techniques, quantization, also are changing how we can apply machine learning on device or stuff like that. But on the tooling side, there's a lot happening. We had a short chat about MLOps and...
Are you doing inference on device?
No, we're not. No, we're not. In my use case, no, or not yet, I'd say. But it's something that opens up these possibilities where, I don't know, 10 years ago that would be unthinkable, to have big models.
But now you could.
Exactly. Exactly. In terms of the tooling, MLOps is, getting more mature. We've shared some frustrations. I'm sure you've all had your problems and issues with brand new frameworks that come out, but it's still a game changer. I'm thinking of the first machine learning team I was a part of. To get our first deep learning model in production took us a team of 10 in 2 years. This was in 2015. And now if you have one person and a few months, you can probably get something together, which is, a game changer.
Aleksandra.
Yes, I can confirm the same, right? Today it's quite very easy to experiment with neural networks. Just grab a model and run it. You need, I don't know, a day or two if your data is prepared and you just want to experiment. So we use, for example, Hugging Face. So we also use always pre-trained models. We maybe retrain the last layer on our type of data, because it's specific, food and so on. But it's quite easy and quite simple. You don't need to think about these things. So if it works, relatively good, so you are getting the metrics that you expect, or I don't know, computational efficiency and so on, you're not going to try to build something on your own. So
Yeah.
I think it's super easy these days to start and experiment with deep learning models.
Are there any solutions, frameworks that came out that you're most super excited about?
I mean, we use. I think it's really easy for the data. For the data scientists to use notebooks in the cloud, for example, I would say, instead of running something locally and maybe waiting, or you could not work on do something else, just run your notebook model on the cloud. I think this is something that I think I see in my a career path, let's say, when I would used to run something on the computer and just go or run it overnight. Now, when you run it on the cloud, you can work on some other task or topic in the parallel time. As I said, I think Hugging Face, TensorFlow. This is what we use on daily basis, right?
Really cool, thank you. Antonio, anything you're excited about?
Many things. I agree with Aleksandra and Camille about how the tooling has got so much better in the last years. It's impressive how much we can do by just paying a bit of money to GCP or AWS. It saves so much time that 10 years ago, it would have been unthinkable that you could start an instance with 4 GPUs by just asking for it, And that's really amazing. I think it also leverages the playing field for people who have good ideas, like this combination of easy access to tools for deployment and experimentation with the wide variety of open source packages with pre-trained models. It's quite exciting. Tools like Detectron are amazing. I don't know if you know what Detectron is. It's a repository that Facebook AI has been maintaining for the last years with all the state-of-the-art object detection algorithms, instant segmentation, semantic segmentation, panoptic segmentation. It's amazing. If you haven't tried it yet, please do, because I know many people who have started companies, startups, just using Detectron. And this is something that would have been unthinkable 5 years ago, even.
It's true, yeah.
Yeah.
I just, this weekend, I tried Whisper from OpenAI, which is multi-language speech-to-text with super high accuracy, even to different accents and noise, and then I connected to Bird, and within 20 minutes you have an audio summarizer,
Wow.
which is super cool. This was not possible just a few years ago.
Yeah.
Incredible. Do you have any, or in your day-to-day work, what are the biggest obstacles that you face when implementing new machine learning or deep learning systems?
Convincing people that it's worthwhile.
How do you do it?
Build a simple baseline that has no machine learning at all, a
Wear a
rule-based
suit?
model. Sorry?
Wear a suit?
Wear a suit?
Was a joke.
Wear a suit? I'm thinking about this joke too.
Baseline models.
No, I think it's the opposite in our field. I think you get more street cred if you just wear a hoodie. So yeah, it's actually the way to get trust from stakeholders is to actually build a very simple baseline, like a stick and stones approach that has zero machine learning, and then show how you can improve on this baseline by adding complexity. And you have to do this iteratively. You really need a dashboard.
Yeah, something to show, no?
Exactly.
Something visual.
Nobody in management will trust you if you don't give them a dashboard.
I think that's a very good career advice. Aleksandra, what are the biggest issues you're facing?
I agree about the dashboard. No, we always deliver. So I would say data quality, and then the opposite, convincing data scientists not to start with deep learning methods, not to go with the most recent research papers and so on, because when you work in an industry, the data quality is the biggest challenge. You are dealing with a data mess, so you really need to identify the data mess and improve it if you can, standardize it as much as possible, and only then start working even with a simple machine learning model. And then when you have the baseline, then go wild. I say always select at 2 to 3, so maximum 2 to 3 other models that you want to try, but think that there are different approaches. So go with, I don't know, forest, random forest, XGBoost, but then go with maybe deep learning and then compare. And I would always advise them to not to try 3 different, like don't try CatBoost, XGBoost, and the random forest. It's very similar. So I think those would be the struggles.
Data quality.
And then convincing to this simple first and then complex. Occam razor.
That makes no sense. Before I worked in industry, I really couldn't believe the data quality is really such an issue, because at university it's also nice.
In academics you get the best data you can. So this is high level gold standard benchmark data set that everyone compares against, like IMDb data set or something like this, and then you just try to improve the metrics a little bit. But when you try such a high-level model, like a state-of-the-art model, to a real data, it doesn't bring much.
Yeah. One of my first jobs was consulting for a retail bank, and they failed an audit because somebody came in and they went through the database and they asked, what does this color mean? What does this color mean? What does this color mean? Which seems like a simple question, but if your database is a couple years old, it can get really difficult to answer. Camille, what is the biggest challenge for you right now?
I mean, these are great answers. If I picture an ideal world where I have an incredible data engineering team so I don't have to worry about data quality, and I have a business team that loves my dashboards and trusts them, then I would say the next problem would be it's really, really hard to do science at scale. And because of the experimental and iterative nature of machine learning, you kind of have to do that. You'll have very quickly different teams working on different but related problems, and most of the value you're getting is actually disproving approaches, right? It's like, this doesn't work, this doesn't work, this definitely doesn't work. Maybe this has potential. And if you don't coordinate this, as you would like a research center or something, you're going to have issues, or you're going to be very slow.
And it's very difficult to implement this in Scrum, especially questions like, when is the data exploration done, finally?
Yeah, exactly. I think it's hard from a management perspective, from what tools you use to even like communicate results. Having one place that everyone reads and can be shared, or even, I don't know, meetings to share information. But when it's done well, I think that's when you leverage deep learning for innovation.
What are your biggest success stories? Or your biggest success story for deep learning?
I mean, it's going pretty well right now at Watergenics. We took this fairly niche field, and basically, I think we had a bit of a edge on timing, where it's historically a field that is more scientific and less from the software data science side. And also, we took a very data-centric approach, where we focused on gathering big data sets, making sure they're the highest quality. And so far, so good. We beat.
Have you manually annotated them?
Sorry?
Were they manually annotated?
Yeah, and gathered everything. So we built an optical lab, built a chemical lab, got everything running, and that's how you get an advantage in this
Really
field.
cool. Really cool.
It's been fun.
Thanks. Aleksandra?
Yeah, I would say solving this, the project that I also present today, because it is a topic that have been tackled at least 5 times in Delivery Hero, and I was like observing 3 failed tries to solve this normalization and categorization. So I'm really proud of myself and the team that we were really able to achieve this in a very short time with really good results. And really, again, I think it was really satisfying for the data scientists to try out different methods to see this running in production and unlocking different use cases. So yeah, but I'm looking forward to other challenges, I have to say. Yeah.
So you're looking for new jobs?
No, I'm looking forward to what other, I think now identity resolution is also very painful in Delivery Hero. So this is also another topic that I'm now super excited about to solve.
Thanks so
and maybe
much.
next year presenting. Yeah.
Of course. Antonio, what are you most proud of?
My students at data science retreat.
Yeah?
Yeah, they usually do really cool projects with deep learning, and many are focused on computer
Are there any
vision.
cool projects that came out of this that you can share?
Actually, we built like a very interesting art recommendation system using deep learning a couple of years ago. I was really proud of this pair of students who built this thing. But maybe to take it back to business, we're not using, at my particular company, like right now, deep learning for this delivery time estimation project. But at my previous company, at Home2Go, we had a very successful use case for deep learning when we were boosting the search results for vacation rentals in the summer that showed a pool in the picture. So we built an image classifier for pools, and we showed these results at the top of the search results for vacation rentals in the summer, and this boosted conversions for a huge amount, like 12% more conversions, just by picking pools in the first search results at Home2Go, and this actually was worth millions for the company in the long term. It was actually like a quite good use case for deep learning.
Really cool. Thanks so much. Antonio, Camille, Aleksandra, maybe a small applause.